Section 8.3, dividing polynomials. The objective here is to divide one polynomial by another polynomial. So a simple rule here is to think of long division and remainders with numerical values and then apply those same rules to variables and polynomial expressions. So let's take a look at an example. If I said, what is 41 divided by 3? And you look at this with long division. You put your 41 here and be divided by 3. So you would take your dividend and divide it by your divisor, giving you the quotient as an answer. So with long division, we say to ourselves, well, how many times does 3 go into the first number? Well, it goes into 4 once. So we put a 1 up top. Then we take this 1 here, multiply it by 3, put it down here, and we remember to subtract it, giving us a 1. Then we carry down the next value, which is 1 here. We say, how many times does this 3 here go into 11? We know that that answer is 3. Now, we take 3 times 3, and that's 9. We put 9 here. And then we remember to subtract again. When we subtract 11 minus 9, we get 2. Now, if we take a look at this, we know at this point that 3 cannot go into 2. So either you start by putting a 0.0 here and then keep going, and then you would realize that you would get 0.66666 repeating. So if you had put 0.000, you ended up getting 0.6, etc. So 6 repeating. But we're not going to do that. We are going to instead think about this as a remainder first. So let's not put this here just yet. Let's think about this as a remainder. So we write remainder 2. So that tells us that 13 with a remainder of 2, okay, is our answer when this value of 41 is divided by 3. Well, that's actually really just, as we said, 13.6 repeating. But if everybody knows their decimals, 0.6 repeating is 2/3, so this is really 13 2/3. Well, the 2 from the remainder ends up as the numerator of the fractional part of the mixed number, and the 3 as the divisor is always the denominator of the fractional part of the mixed number. The whole number part of the mixed number comes from, again, your quotient right here. So now let's apply these rules to polynomial division. Example 1 says to divide x squared plus 2x plus 4, that quantity, by x minus 3. You could start by saying to yourself, well, this is what it means, really. But what we'll notice is that you can't factor the numerator. So we can't factor and then cancel. It doesn't work because it's not evenly divisible. So let's go to long division and see what we can do. So we start with dividing x minus 3 into x squared plus 2x plus 4. And I'm deliberately leaving a little bit of space here and here just to keep track of my columns we're going to see in a minute. So let's go ahead and apply the same rules as we would long division for numerical components. We start by saying what quantity always needs to go up here. That's what we really do in long division. And then we take that quantity and multiply it by this and put it underneath. So what value can I put here that when multiplied by this expression ends up giving us an x squared, ends up canceling it, so we can keep reducing in our staggered motion? Well, what happens is if we put an x up here, this gets multiplied by this quantity right here, this x minus 3. So x times the quantity x minus 3, we have to distribute it, becomes x squared minus 3x. Okay, again, when I multiply it through, that's what I get. But remember, with long division, we have to subtract this whole quantity. So really we have 2x minus negative 3x, well, that's 5x. And then, as we said a moment ago, we're trying to get these to cancel. That's really the goal. X squared minus x squared, well, that's just nothing. So now we've got 5x left here. We have to remember to bring down the next value. And there's a positive here, bring that sign down as well. So now we have 5x plus 4. So the question now becomes, what quantity should be placed up here? So when multiplied by this, it gets rid of the 5x. Well, that would just be a 5. Because if I go ahead and put 5 up here, and I take this 5 and distribute it to both of these terms, I get 5x minus 15. That goes right here. But remembering that we have to subtract that whole quantity. So as a result, 5x minus 5x is 0, and then we get 4 minus a negative 15. Well, that's going to be 19. Now, what does this mean for us? Well, clearly, we cannot put another value up here, because if we multiplied it by something with an x, it wouldn't cancel with this 19, because that has an x and that doesn't. So we stop here, and this becomes, like in the last problem, our remainder. So if you remember from mixed numbers a moment ago in long division with numerical values, the final answer was a mixed number that involved the quotient being the whole number portion, the remainder being the numerator of the fractional portion, and the divisor being the denominator of the fractional portion. So our final answer is really x plus 5 plus, now I'm putting plus because the remainder is positive, plus 19 over x minus 3, which is the divisor there. So again, remainder over divisor is the fractional part, quotient is the whole number part. So this is the answer you would get when dividing these quantities. And we're going to see where this is applicable, because this is not just doing this just to do it. But really we'll see its application with rational functions and their graphs. Alright, example 2 says 2x squared minus x minus 3. We'll take that and divide it by x plus 1. So let's go right to long division here. First we'll start, let's put a 2x up here. So when multiplied by x plus 1, we get 2x squared plus 2x. We remember to subtract that. 2x squared minus 2x squared is 0. Negative x minus 2x is negative 3x. Well, how would I get a negative 3x to get rid of it? I put a minus 3 up here now. So negative 3 times x is negative 3x. Oops, I didn't bring down my negative 3 here, right? And negative 3 times 1 is actually also negative 3. I remember to subtract this whole quantity. And I get 0 as a remainder. Right? When you subtract anything from itself, it's 0. So there's no remainder in this problem. Well, think about this for a minute. If I had 27 and divided by 3, well, the answer is just 9. 9 times 3 is 27. What's the remainder? 0. So this means that 27 is divisible by 3 evenly into 9, or giving you 9 as a quotient. So that means that this quantity is divisible by this number, giving you this quantity, or this quantity rather, not number, giving you this quantity as a result, because the remainder is 0. So 3 times 9 is 27, so this times this is really this. So 3 and 9 are factors of 27, so these are the factors of this quantity. So again, this tells me that 2x squared minus x minus 3 factors evenly into x plus 1 in the quantity 2x minus 3. Example 3 says divide 3x squared cubed plus 2x minus 4 by x squared plus 3x minus 5. So we're dividing by a quadratic here. We're noticing that our dividend is a cubic expression. Noticing though that x squared is missing. So we're dividing by a quadratic into a cubic. But since there's no x squared term, I'm going to go ahead and put a 0 in its place. Okay, and I start by saying, alright, well, I'm going to definitely have to put a 3x here, because 3x times x squared gives me 3x cubed. Then we go 3x times 3x gives me 9x squared. And then 3x times a negative 5 gives me minus 15x. I have to remember to subtract that entire thing. I'm going to have 0 minus 9x squared. Now 2x minus negative 15x is going to give us 17x. Now I have to bring down the negative 4 at the end, so I put a minus 4. So then I ask myself, and again I can erase this really, right? Then I ask myself what quantity needs to go up here. So when multiplied by x squared, it gets rid of a negative 9x squared. Well, it's got to be negative 9. Negative 9 times x squared is negative 9x squared. Negative 9 times 3x is negative 27x. And negative 9 times negative 5 is 45. I subtract that entire thing. Negative 9x squareds cancel. I get 17x minus a negative 27x, giving me 44x. Then I have negative 4. Oops, I forgot to put the minus, but I've been doing it. Then I have negative 4 minus 45 is going to give me negative 49. So that means that this is my remainder. So the final answer here becomes the quotient 3x minus 9 plus, again, the remainder over the divisor.